our test got recorded. So yes, midterm is May 15th. All right, questions?
What's a class?
What is a class? We're in a class. So I'm very close to pulling the plug on IntelliJ, in which case we would be going back to Eclipse. And I'm going to mess around with it a little more tonight, but how many people here have tried doing any of the graphic stuff that we've done with IntelliJ?
I made a very basic multiplier. I have to have two numbers though, or it will fault and create error messages.
Okay, so you got buttons and stuff?
I only have the OK and cancel button, and I use the OK button.
Oh, okay.
Multiply.
But it's actually working.
But it seems to work.
Okay. Are you running Windows or Linux?
Well, I use the computer lab over here.
Okay. In the laboratorium?
Yeah.
Okay, because those I know work. Anybody else been playing with the graphic stuff yet? Okay. A few other people have, and for the most part, it's not working very well. It's exhibiting flakiness, where it does different things each time that you try, and in some cases, it's just not doing some of the stuff we want. So I don't know. I'm going to dig a little more into it, but I'll make a decision tonight, and we may go back to Eclipse. And I want to do some Eclipse anyway because I believe WSU is still using Eclipse. But we may use that for PA3. So, but let's play around with this a little bit.
Well, that's a shame because I just downloaded IntelliJ onto my computer last night.
Well, if it's working on your setup though, it's a good one to keep messing with.
Well, I haven't actually booted it yet.
Okay.
So I haven't figured out if I haven't running into problems too.
Okay. It's my intent was to primarily use IntelliJ, right, and use that for the programming assignments, but to definitely spend some time going over Eclipse because that's still what a lot of places are using. And so we may just flip that around. We've spent some time looking at IntelliJ, but we may use Eclipse for the main programming assignments. And in an ideal world, I'd give you your choice, but I can't do that with PAs because then I'm going to end up having 5 or 6 different environments I have to use to test, and that's just not going to be practical. All right, so let's play around with some rectangles and stuff. And I'd be really interested if people want to try doing this later on today and post on Canvas success or failure or troubles, just to kind of get an idea how widespread people's experiences are. So I'm going to go down to source. I'm going to right click and say new dialog. I'm going to take off the OK and cancel code. So the buttons will still be there, but I'm getting rid of the code that it generates, the handler. And I'm going to come into the form and I'm going to actually delete those. And I'm going to put a button over here. And I'm going to put a J panel in here, but it's going to be my extension of a J panel so we can do some painting. So I'm going to make a new Java class called, we'll call it panel 223. And panel 223 extends JPanel, which comes from Swing. So I'm going to come into my form area. I'm going to come down to non-palette component. I'm going to drop that right here. And for the class, I'm going to say that's a panel 223. Go ahead and create the binding. and say OK, and there's our panel. And it's going to complain that it doesn't find it, I think because I haven't built things yet. So let's go ahead and build. Yeah. Try this once more. Alright, so looks like you have to do a build to compile your panel class before you try to drop it. And if you drop it in there first and then you compile after, it's going to complain. And if you do that, you should be able to uncheck this custom create, but that's one of the things I was trying with a student earlier and it wasn't working. Anyway, we have a panel 223. I want it to be bigger, so I'm going to change the alignment to be fill for both vertical and horizontal. And if I run this, I'm going to go to my main code, I'm going to say run, tell it I want to run from main, and I should just get an empty window up here. So let me change the background. I'll just make it a kind of pukey yellow. It's not showing up. Okay, so this is another thing I keep discovering is when you change things in the properties window, you have to actually move off of the properties window, and tabbing doesn't seem to do it. Tabbing, like, it's changing my indent level for some reason instead of moving me to the next property. So, but anyway, so we've got a panel now, we've got the background set. And so there's our panel. Alright, so you remember how we paint things on here?
We do a super or J panel.
Yeah, so so create your own panel class. Extend JPanel. So you've got all the stuff that comes inside a JPanel anyway. And then override paint, which takes a graphics object. So let's make our public void paint graphics G. So let's set our color to red. Let's make a red square. And then let's set our color to green. And let's make an oval. And all the red are errors, so let's go ahead and Alt-Enter to get the graphics class. And then we need to get the color class. That's a period. Alright, so there's our own paint method. It's replacing or overriding the paint method in JPanel, and everything else in JPanel is part of our panel 223. And so if I run this, there's our rectangle, there's our oval. So this is basically where we got to yesterday, right? All right, so what I want to do is I want to start interacting with the paint method and see if we can change what's being displayed. Let's try moving this rectangle. So what I want to do is when you press this button, I want to change where that rectangle appears. So I'm going to right click on button, I'm going to create a listener, I'm going to say action listener, action performed, and I'm going to be right down here when the button gets pressed. And we want to move the rectangle. So in a straight procedural environment, we would do something like draw the rectangle, right? We say g.fill rectangle, and we'd have some xy coordinates, and we would change those coordinates each time. So let's do some update. So let's in our class, let's save our X and Y location where we want to draw the lower left corner. So we're going to start that off at 40, 40. And when you click the button, let's increase each of those by 10. And what we want to do is draw a rectangle with the lower left corner at X location, Y location. But we can't say draw a rectangle, right? We can say draw a rectangle inside our panel 223 class because that's a J panel, so it's got a paint method. But we don't really have a way to say draw a rectangle right here. And there's two real issues. The first issue is we don't have a graphics object. We could construct graphics G equals new graphics, but it's not going to be the graphics object that draws in that window. So that's the immediate issue. There's no G that we can use to call draw rectangle, fill rectangle. But the bigger challenge here is that we really only want one thing doing the painting. And Swing is this collection of software that's sitting in the background that's updating what we see on the display, is doing a lot of painting. It's displaying these frames and the backgrounds and coloring them and all that kind of stuff. And if we start trying to do some painting of our own in here, things are going to get muddled up. Okay, so you have a canvas and you have an artist making a painting and somebody else comes over and wants to draw something on it. And so they push the artist out of the way and they grab a brush and they do some painting and then they walk away. And the first artist comes back and they can't easily pick up where they left off. They're going to conflict with each other. So we really want to stick to doing this painting inside that paint method that we've already got inside panel 223. But what we want is after you click the button, instead of drawing this rectangle at 40-40, we'd like to draw it at 50-50 or 60-60 or some other location. So here's what we want. We want to draw at some XY location that can change. Well, these need to be variables in here, so we'll make them local variables, so that's all fine. There's only one thing missing at this point. When I click the button, these variables get incremented. Those have nothing to do with these variables that are used to draw the rectangle. So how do we link those together?
Make some setters?
Yeah, make some setters. So we know that panel, right, it's declared in here to be a panel 2231. That's the name of an object of type panel 223. So let's make a setter. So let's say panel 2231 set XY location. And I could make a setter for X and a setter for Y, but I'm always going to do them at the same time. So I'm going to make one setter called set XY location, and I'll pass it an X location and a Y location. And it's red because we haven't made set XY loc yet, but we're about to. So this has got to be public. And it's not going to return anything, so it's going to be void. So that's the location for the lower left corner of the next rectangle we draw. Make sense?
Mm-hmm.
So let's run it and see what happens. Got our rectangle, got our oval, click the button. Nothing seems to happen.
Did you compile and start it again?
It is compiled. That's a good guess though. But something interesting will happen if I grab a corner and I start to resize. Our rectangle jumps.
You don't refresh the display.
We don't refresh the display. Now when I resize, the display gets automatically refreshed. But unless I do that or something similar, I've changed those locations, but this call to fill rectangle is not happening. So what I'd like to do is after I update X location and Y location, after I use that setter, I'd like to call the paint method so that it goes ahead and does the paint. But I can't call paint because I don't have a graphics object. So the way you do this in Swing is you call a method called repaint. And repaint doesn't take any arguments. And it basically says to Swing, I would like this component to be redrawn, to be repainted. In other words, I'd like you to call the paint method. Something has happened, this needs to be updated. And repaint won't call paint right away. In fact, it'll come back to you almost as soon as you make this call. But then sometime after that, paint will get called. And so if 50 different things all request repaint, at some point paint might get called once on behalf of all of the people who requested it. So we'll go into main and we'll go ahead, we'll update X and Y loc. We'll set those in the panel object. And then panel 2231 we'll call the repaint method. So now we run this, and every time we hit the button,
Ooh,
our rectangle moves.
that doesn't look like a moving rectangle.
But that's not exactly what we were thinking, right? There is a moving rectangle, but there's other stuff too.
That doesn't update until you move the screen, does it?
But if I move the screen, there's what we wanted.
Shouldn't we,
Oh, it repaints, but it doesn't refresh.
Basically.
shouldn't you add a rectangle of the same size but with the color of the background maybe?
We could do that. We could erase the old rectangle. Or we could erase the entire area. But there's an easier solution in this case. And sometimes this is a feature. Sometimes we want this to happen because it looks kind of cool, right? But it's not really right to do it the way that we've just done it. So here's the thing. Panel 223 is an extension of a JPanel. JPanel has a paint method. One of the things the paint method does is it clears the background, sets it to that uniform color, draws the title bar, all that kind of stuff. When repaint is called and panel 223's paint method is called, what happens? 4 things. Set color red, draw a rectangle, set color green, draw an oval, that's it. None of the other stuff that a JPanel's paint method does is happening anymore. So almost always in the beginning of your paint method, you want to call the paint method from the original class. So super is a keyword that says the original class that I extended. So that's jpanel. Call the paint method in that. And pass it G, which is the graphics object. So we execute the original paint method. And then we go ahead and we do the painting that we want. So now if we do this, right, and it's back to being yellow, because when we laid out the form, we set the color to yellow to see where it was. Well, that wasn't happening because our paint method didn't say set the color to yellow. Okay, but jpanel's method does say that. And now when we click the button, our rectangle moves.
Hey.
Yay. And when it gets to where the oval is, it goes underneath it. Why is that?
Because oval is newer than square.
Yeah, because oval is newer than square. We draw the square first and then we draw the oval. If we change that and we just draw the oval first, then the rectangle's on top. So this is sometimes called the Z order, Z being the axis that goes in and out of the screen. And Z order is often really, really important. Right? It basically controls what's effectively on top of something else. So this is generally how we're going to connect components together. We're going to have to create methods and pass things around. And our main class that's constructing all of this stuff, right, this code which we didn't write but got written for us, among other things, creates this panel 223. And so we have access to that and we can get to its methods and we can use those methods to pass information around. So that's a common model we're going to see throughout all of this. And incidentally, if we switch to Eclipse, none of this changes. Okay, the way that you use the IDE to drag and drop components and all that, that changes. But the code itself, the concepts, the paint method, all of that's the same regardless. Okay, the IDE is just the way that we're writing the code.
Doesn't Eclipse give you more freedom with where you can place things?
Yeah, Eclipse has an absolute layout manager if you want it, so you can just drop components and they don't move around. And components don't start off with a size of 0 and all this other stuff. And let me tell you about Eclipse. So if you just do Eclipse download, your first thing should come from eclipse.org, as long as it's coming from there and not some random site. You can just go to the download. And for Linux, it's only going to give me one option. For Windows, you might get multiple options, but you basically just want Eclipse for Java development. If it gives you an option, you can use SE, that's the standard edition. And you can mostly just take defaults. So this is going to bring down a tar file, right, which is Linux. But from Windows, you'll get a zip file, I believe. So even if we don't decide to use this for PAs, good idea to go ahead and download Eclipse and install it and make sure that it runs. But we'll talk about details of that in a few days. All right, well, what else can we do? So let me put our background back to something reasonable. Go with black. So I want to play with the mouse, and I tried to do this in the morning class and it did not work, but I figured out how to make it work. So I want to pick up when the mouse moves. And if I say mouse listener, there's an option there for mouse move, which is what I tried to use this morning, but it doesn't actually work. I don't know why they have a mouse move under mouse listener. So I'm going to go to mouse motion listener, and I'm going to say mouse moved, and put my code in here. Get a prime number of characters. All right, so I'm going to run this, and there's our window, and when I move the mouse under here, it's going to tell me the mouse is moving.
The window's black.
My window's black. I set the background to black because it's more dramatic. All right, so we want to figure out where the mouse is each time that it moves. Do you remember how to find the mouse position?
There's a method for this.
There is a method for this. So mouse moved is the thing that's being called when the mouse moves, and it's being passed one argument, which is an object of type mouse event. So if we look at the documentation for a mouse event, and it's Java AWT events mouse event, mouse event. We can find out about that object that's being passed to us, and it has a getX and a getY method. So that'll tell us the coordinates relative to the panel 223 where this mouse is located. So mouse event get X. Did it both times. All right, so we'll print out a message, but we'll also print out the result of get X, get Y. So we can pick up coordinates here. Upper left corner is pretty close to 0, 0, and lower right is whatever it happens to be. And I set this panel to have a fill option so it grows as the window grows, so we can get to larger coordinates. Did I just close my IntelliJ window? No. All right, so we have a way to find mouse positions. So what should we do once we know the mouse positions? What would be fun?
Making a square follow the mouse?
Make the square follow the mouse. Cool. All right. So let me get rid of this print message. And what's our magic here? All we got to do is panel 2231.setXY location. So we read the current XY positions, we use that to set the location in the panel object, and then we're going to go ahead and call repaint. There we go. That's the upper left corner, not the lower left.
Huh. That's interesting.
Yeah. And it's 2 lines of code instead of what we were doing before.
What happens if you click button?
If I click button, it starts moving this,
But it goes back, okay, it moves it back.
right? But it remembers where it was on this.
Okay.
Now I could tie those together.
Mouse click sets the location to that spot.
So in my main, I have my own copy of X location and Y location, and that's what I'm using to set, and that's what I'm incrementing when I click the button. So that's keeping its own position independent of where the cursor moves it. Moves the rectangle and the mouse event. So that's just kind of an artifact. So check this out. What happens if I get rid of the call to the super classes paint method?
Nothing works. Hey, you can draw.
We can draw. I made a pair of eyeglasses.
Uh,
Very red. So again, that's not the right way to do this.
Can you make it so that if you click the window and shake it, it all goes away?
Yeah, we could.
Make an etch and sketch.
That would be fun. So this is a really kind of like quick and dirty way to do a drawing program. But you know, if I resize the window, everything goes away because that's calling the repaint method. So suppose I wanted to do this the right way. Suppose I didn't want to just rely on the fact that I'm not clearing the screen, but I wanted to actually make a drawing program. What might I
mouse
do?
Holding the mouse trigger.
So I could hold the mouse trigger to actually draw,
Which would be
but I'm
interrupt.
only filling a single rectangle here each time that paint is called, assuming I put my
How big?
color
depends on
back
how
in.
big your rectangle is.
Okay. So how could we draw multiple rectangles? I think 222.
You make multiple rectangles every time you have clicking in your mouse button.
Mm-hmm. What if we made an array of X and Y locations? And every time that we moved the mouse, we added another XY location to that array, and in our paint method, we went through the entire array and drew rectangles at each location stored in that array. So the array is empty to begin with. You move the mouse to one position, and the location of the XY coordinates of the mouse, that goes into your array. And when you call your paint method, it finds one pair of coordinates, it draws a rectangle there. You move the mouse to a second position and you add those XY coordinates to your array, so now your array has 2 coordinates, the old position and the new position. You call your paint method and the paint method goes through the array and now it draws 2 rectangles, one at the old location, one at the new location. And you keep doing this for however big your array is or however long you want to draw this. And this is something like a queue or maybe a stack. So let's try this. Let's make an array X location, Y location that'll hold 50 elements. And index is going to tell me where I should save my next XY coordinates. So I'm going to start off by saving at element 0. And each time we save, we're going to bump up index so we store in the next location in the array. So my set XY loc is going to do the following. I'm going to save XY in this array. And I'm going to increment my index.
What happens with his ceiling?
Oh, you're going to save us from having to do this twice. Alright, so we'll fix that in a sec. So we're going to fill the rectangle and we're going to use X location I and Y location I. So yeah, right now when index gets to 50, we're going to get an out of bounds exception. What would be a good thing to do there?
And make a linked list of.
Oh, we could be fancy and make a linked list, but I'm being lazy.
Make a reasonable sized array.
It's never going to be as long as we want, but that would help. Did you have an idea?
Just replace
Reset it.
at.
Reset it. So our first rectangle is going to go at index 0, next one at index 1, all the way up through index 49. If we get a 50th mouse motion, if we put that back in location 0, now our array has the last 50 coordinates, and that coordinate from 51 times ago gets lost. So we've got basically like a circular queue here, circular buffer. So if index hits 50, index will be equal to 0. I could also just set index equal to index modulo 50, but we'll be explicit here. All right, should we see what this does?
A snake.
It's a snake.
You can play that snake game and it can always increase.
Yeah.
So you run into yourself accidentally with the most recent one.
There we go, I'm dead. Actually, it's a challenge to run into yourself.
Can't you make a snake program by just like making an interaction where you move over the XY coordinate of the dot and
Mhm.
increase the index?
Yeah, totally. So there's a proper drawing program, and if we wanted to have this thing remember more than 50 coordinates, we could go to a linked list, right? And hope that we don't draw so much that we run out of memory. Or we could only add points if they're not already in the linked list.
You could also make the button so if you click it, it just clears the list.
Could make the button so it clears. Instead of doing that.
When you click the button, does it shorten the length of the actual?
I don't think the button is doing anything in particular right now,
It's
except
just
drawing a
array
rectangle
is
right
okay.
there.
Well, it's taking. Oh yeah,
Oh yeah, because we changed set XY loc.
because.
Okay, so yeah, it's breaking our snake and it's drawing it over here. That's pretty cool. And we can do this, move in one position. So just an example, right? This is tying code together with graphical elements, right? But the actual code involved in all of this is pretty minimal, right? I mean, that's really all we wrote. It's just a circular buffer and a for loop inside Paint to read the buffer and draw rectangles.
You could technically also have a program that could change the color of the square.
Absolutely.
With another button press.
Yeah, so we could have red, green, blue buttons, and we could click those to increase the amount of red, green, and blue, and we could use those in our set color method. Because set color can be called with red, green, blue integer values, and it could adjust the color accordingly. So this is how you make like a color chooser, where you can put in the amount of red, green, and blue, and you see a little swatch. That's the corresponding color. All right, so this is the kind of stuff that we can do and that you'll be doing in subsequent programming assignments. And there's a lot of stuff going on under the hood that's kind of hidden from view here. Eclipse actually exposes it for you, which is kind of nice. But the code we have to deal with is pretty small. So, as I've mentioned, I'm leaning towards PA3 is going to be a calculator program instead of tic-tac-toe game, just because it's something different to do.
What kind of calculator?
Well, probably going to be a pretty basic calculator that will have 10 digits and a decimal point and can add, subtract, multiply, divide, and do equals, and a clear button. And I'm not sure how much beyond that I'm going to ask for, but there are certainly embellishments one can make beyond that. But let's look at basic calculator. I'm going to put myself in airplane mode. Alright, so there's my calculator. So I can say 23, what?
That's not entirely basic.
It's not entirely basic. 23 plus 45 equals, and I get an answer. So if we want to make a program that does this, right, obviously we're going to make buttons for, 0 through 9 and decimal point and plus, minus, times, divide, equals, and so on and so forth. But I want to think about what kinds of things does our code need to do to process these button presses. We can basically say when you press this button, jump down here and execute some code, but what kinds of things will we put in that code?
We need to be able to analyze the code to look for different integers and operands,
Okay,
like a stack.
so if we hit the 7 button, we'll go to a set of code that's dedicated to, run this when the 7 button gets pressed. And if we hit the plus button, we'll go to another piece of code that's called when the plus button is pressed. So we'll have separate sections of code for each button. So what happens when we press, say, the 1 button or the 5 button? What kinds of things happen?
You save something to changing variable.
True. What did you say?
You display it on the screen?
You display it on the screen. So if I hit a 5 and a 6 and a 3, those get displayed side by side, kind of like we did with our binary calculator, right? But if I happen to have hit a plus sign, now when I hit a 5, something different's going to happen. It's not going to show 5, 6, 3, 5. It's just going to show a 5. So we're getting to the notion of state. Right? We keep talking about state and stateful programming. This is classic stateful behavior. 1 button, numbered 5, when we click it, different things can happen. If we've started typing in a number, we should just append the 5 to the end of the number. If we just hit an operator, like plus or minus, we should clear the display and just fill it with a single number 5. So there's a couple of states at play here. One state would be waiting for first key press. That's the state when we first turn the system on, when we first start running our code, and we're waiting for something to be pressed. So that's one state. Another state is entering the first number. If we're waiting for the first key press and we hit the number 5, we display the number 5 and we change to this state where we're currently entering the first number. If we're waiting for the first key press and we enter a 0, we're still waiting for our first key press. If I hit a 5, it's going to replace the display with a 5. But if we're entering a first number and we hit a 0, we treat it like any other digit, we just tack it on. So again, same button, different behavior depending on what state we're in. So we need at least these two states. When we press an operator, that's a third state. So if we've just pressed one of these operations, now the next time we hit a button, it's going to be the beginning of entering a second number. And the first time that we hit a button after entering plus, minus, times, or divide, we should clear out the display and replace it with that digit. But subsequent times when we hit a button, it should get appended to the right of the number on the display. So there's entering second number, and so on. So different states that we're going to have to keep track of. So this is going to be part of our challenge if we decide to do this, is sort of understanding the stateful behavior of this program. Because there aren't that many inputs. There's numbers, there's operations, there's a period, and an equal sign, and that's about it.
Shouldn't there be a state for the equal sign?
Yes.
operator then?
So when you hit the equal sign, we're going to go to a different state, which will be pretty close to where we're waiting for the first key press. But if we hit the plus button after we've entered two numbers, we're not exactly in that first state, because now if we type a third number and hit plus, it should add that to the sum that we just calculated. So 2 plus 3 plus 5 should give us the sum of all three. So different states we're going to need to keep track of. And once we understand those and we've got them written out, then it's like drawing the rectangle. There's going to be a few lines of code to make all that happen. So a big part of the challenge in doing this kind of programming is understanding your data structures, right, which isn't really an issue in this, but also understanding the flow through the program, the stateful behavior in this case. All right, we're past time, so we'll talk more about this tomorrow. Spend some time on IntelliJ if you can, and let me know how well it's working or not working for you. Post something on Canvas if you can. Oh, thank you. Did everybody sign in?
One more. Oh, one more? Excuse me.
Yeah. Sure, yeah, that's fine.
I just need to try to figure out how.
Yeah.
On the step down. There's a cut in this board.
There is.
Should you use